This is my hopefully final attempt. Last time it was alright, but my fucking iPhone decided it would be funny to orient the video up and so that way the left and right was up and down because it does that for idiots who hold their phone wrong. So I'm going to start off from this perspective. So that way it hopefully orients the camera correctly. And also, when I refer to idiots who hold their phone wrong when recording themselves, yes, I'm referring to fucking morons like Joshua Feuerstein, and he's a fucking moron for many reasons, but that's just one reason right there why he's really, really not a smart person. So anyways, here's my stuff on 3D perspective. So I calculated this sort of thing back in high school when I was really over medicated on ADHD meds, and I came up with all these ideas, and I had to immediately get some graph paper and sketch them out. So here's my idea on 3D perspective from a mathematical perspective in practice. A bunch of cubes sort of stacked together with their geometry interacting and sort of giving you context clues on space. So yeah, and it looks pretty good to me, but might not to you, mainly because they aren't shaded. That's another context clue that you can give based on space and perspective. But this is just raw, depending on where a single point is in space, where it will appear on camera based on how far left and right, spatially, how far back and forth, and how far up and down, just where it will appear on the frame or the canvas or whatever you want to call it. And I just realized my hand was probably over the microphone, so my voice was probably a bit muffled. I sound better now, don't I? So that's the old equation right there. I don't like it so much, and here's a newer equation. So remember what I was talking about with the back and forth, up and down, and left and right thing? That's what this equation represents. So xf, that's your left and right. So negative, that's to the left of the center of the frame, and positive, that's to the right of the center of the frame. I think you got it. And now YF, that is to the positive, is up from the camera screen, and YF, that's to the bottom. This is measuring on the frame as if it were a piece of graph paper like this one. Then there's also X dimensional. That's left and right, but from a spatial sense, not on the frame, but just raw, my finger is a foot away from the camera right now, that sort of thing. That's this one, ZD, how far back and forth in distance. XD, that's left and right though, so if I were to bring this back so you can see it and then move this over here, that's a foot in terms of XF, well, negative a foot in terms of XF. And which measurement you use, feet, inches, points, units, meters, kilometers, light years, molecule spaces, it really does not matter at all. It actually does not, because if something is 10 light years forward and negative 5 light years to the left, that'll appear as the same point. Well, a infinitesimally small point will appear on the same part of the frame as would something that's only 10 feet forward and 5 feet to the right. Did I explain that well? I hope I did. So that's those equations, and that's based upon this triangle Where's my pencil? There it is. Found it. So this point right here, all points in space, like that one, they converge into there, and so that line right there, that's where it converges on the frame, and for this one there, so like, again, with the units do not matter. If I keep going forward from that line, it'll appear on the same spot of the camera. So really, in terms of like, I was going to go on a tangent. Never mind that. Oh yes, so I mentioned the XD, ZD, and YD, but what about V? So, V is basically takes into account like a camera lens size and shape. So like depending on what kind of lens shape of lens or like size, that'll cause things to be foreshortened more or less. So like the V is calculated basically upon distance between the point of a triangle and the part where the canvas is. Yeah, I think you get that. So like, and what I found is like the V point, if you measure that out on the canvas, so like if a V in this case is like 4, then that, so like 1, 2, 3, 4, that's also the 45-degree, that's where would also be the vanishing point for like a 45-degree line that's drawn out on a sheet of paper that's perpendicular to the camera. So like, if I put this forward, focus on that. Come on, focus, you fuck. There we go. That's pretty perpendicular to the camera. You see that like the lines that go straight ahead, those converge on like the center for this phone camera. You can probably see that in my voice. And like all the diagonals, so like from here to there, that probably converges off somewhere over here on the camera, or it might be off camera depending on like the lens size for this camera. So like the same thing for this picture. So like, and here the V value is 4, so that's the left diagonal, and here's the right diagonal. So now I'm going on to an approximation for that equation. So like this, in the center, that's lines going straight forward away from the camera. So here I've drawn a the inside of like a cube-shaped box using that method. So like, here's one square, and I also divide in sub-squares inside here. So that looks fairly accurate in terms of distance. So what I'm doing is I'm connecting the left diagonal to the right side of this back line that's I've drawn right here. And then wherever that connects on this line that's going to the vanishing point, that's the far end of the square. Now, if so that's how I calculate that sort of a thing. If you want me to make another video going more in depth on this, I can do that. But one thing I'll mention before I end is I often see this misconception of the vanishing point for like goes up and down depending on how far you are from the ground. And that is not the truth. I could probably demonstrate this a lot more effectively in 3D software, but I'm going to try and do this the best right here. Steady, steady, steady down, mister. Alright. Why is my camera a mister? I must be a sexist, patriarchal shitlord. So, anyway, regardless, my camera is perpendicular to that paper, but regardless of if I put put it up, the vanishing point should still be in the center for like lines going straight ahead of the camera. So like, see this going straight ahead. You couldn't see the back side of my finger because it was straight ahead. So if I lift my camera up further away from the ground and do that, point straight at the camera lens, still it aligns perfectly to the center. So what caused the misconception that bringing your camera up and down from the ground changes the vanishing point? Well, it doesn't change the vanishing point for like a line going straight ahead of you, but it does change like where the horizon sits because of the curvature of the Earth. So like a lot of people who are starting on like drawing 3D perspective, they will have a horizon line be the source of the vanishing point, which is kind of a reasonable approximation. And also when you go up from the ground, so right here you can see the paper, but when I go straight up, now you can't. So in order to be able to see that, you must tilt the camera down. So in doing so, that that does change the vanishing point. That's what changes it. Tilting the camera relative to the line that's going away from you. That will change the vanishing point, and not the going up and down, but rather tilting up and down. And same goes for like turning left and right. I made this equation right here, which I don't fully understand on how like tilting the camera affects where the vanishing points go, but I probably need to revise that because I don't really understand it anymore, and you sure as hell probably don't understand that. So yeah, I think that's about it for this video. See you guys around. I will make a follow-up to this if anyone actually shows any interest. That's all. Bye.